Okay, welcome everyone. Welcome to this third lecture of GSOE 9010. So my name's Ned Eakins-Dorks, I'm the convener for your course. And I'd like to welcome new people. I think there are a couple of new people who've joined our course, so welcome. This course is all about developing your engineering research skills. And to remind you, the way we run these lectures is we want to have a discussion. Remember, we're teaching this course in this flipped classroom format. So that means that you folks watch some videos that are posted on Moodle, then you come to this lecture. This is your opportunity to chat with me a bit during the lecture about the topic of the week. And then you have your tutorials later in the week. So the way this works, just to remind you, is over here we've got this sort of questions screen where questions you ask can pop up. Of course, you're welcome just to put up your hand as well. You can log into this thing. You go to socrative.com on whatever piece of electronics is most convenient for you. Click on Student Login and then type in our course code, UNSW 9010. And then you can post your questions up here. One of the other ways you can ask questions in this lecture is to ask them ahead of time on the Moodle. There's a special forum where you can post questions, and I'll check that forum about 30 minutes before I come to this lecture hall. So I didn't see any new questions this week, but I've put an old question from a previous year into my presentation. All right, so let me just remind you what we're heading towards here. This is your schedule. Last week you looked at your rules and roles. This week you're choosing a global engineering challenge. So this is the topic that you'll work on with your project group. Okay, so remember what we're going to do in this course. You folks are going to work together in a project group. You identify an engineering challenge, and then you produce a poster and you produce a movie on that. And then the other main component of this course that we assess you on is your project proposal, which you do individually. Okay, so this week we're thinking about what that engineering challenge might be. And so here is an example of one. Okay, so we're not asking you for much. Most weeks this course doesn't ask much from you. It always asks a little bit though. So we want to make sure you're still awake, you're still engaged. Okay, so this is the sort of thing you might choose in your group. So you might want to solve traffic congestion or address traffic congestion in urban areas. Okay, and then you'd write a short description. Won't take long, but it does mean you and your group need to think about what your topic is and come up with some texts. And then you'll post that next week. Now, many of you will have realized we've got a problem with our Moodle. Yeah, this course usually runs very efficiently around Moodle. Because I've had to group so many tutorials together, that's broken many things on Moodle. So when I say, oh yes, you should submit your Global Engineering Challenge, or you should submit your rules and roles, if you find that Moodle does not work for you, email your tutor with your material. Okay? Moodle is supposed to save us all from having thousands of emails, but when it doesn't work, what we have to do is go back to email. Okay, so if Moodle is not working for you and you need to submit any of these, just email them to your tutor. Most important thing is your tutor gets a copy. If you're feeling very generous, you can send it to me too, but to be honest, there's lots of you, so I'll just make sure your tutor has a copy. But please email your tutor your work if the Moodle isn't working. All right, so the topic of this week is literature search. And so, when I was your age, I'm perhaps older than I look, okay? When I needed to do a literature search, it involved physically going to the library, and there were these paper volumes called abstract books. There was no computer index. There was no Google. Yeah? So what you had to do was you had to look up in indices. You were interested in something, like maybe urban traffic. So you'd look up in this index urban traffic, and it would say, oh yes, these are the papers that have been published this year with that keyword. And then you had to go away and read the papers and see what they referenced. It took a long time. You'd spend afternoons in the library just going from paper thing to paper thing just to find your papers. These days, it's much faster, hugely faster. Okay, so what I'm going to do is show you live in this lecture how we search for information in modern science and engineering. And as you might expect, it involves the internet and it involves doing searches. Google is not a bad place to start, but there are some other quite nice tools you can use. I'm going to show you some of them. So what are we trying to do, first of all, when we're reviewing the literature? Well, the first step is kind of what I had to do by paper, but which, these days you can do on the internet quite quickly, is just to search. Search what has been done and collect relevant materials. Okay, so you need some way of figuring out what's relevant. You can go to the internet, spend your entire lifetime reading new stuff, but only some of it's relevant. So you need some way of searching efficiently. Then you need to evaluate. How do you know which of the things you find are most valuable? Okay, maybe you've already done some reading. Maybe you already have a feel for what's valuable. But if you're new in a field, you don't know, whether somebody is writing with authority or whether they're making it up. So how do we evaluate the quality of the material that we're finding in our searches? And then comes an important step. So you've done all this work, you've done all this searching, you've done all this evaluating. It's very tempting to sit there just clicking on your computer. Oh yeah, that looks like a good paper. I'll keep that browser window open. Oh, that one looks good too. I'll keep that. That one, nah, that one doesn't look so good. I'll close that. All right, that's okay, but then you're going to go to sleep, and then your computer updates overnight. And then you go, all that information that I just found last night before I went to bed has gone because the computer's updated, which is why it's really important that you make notes as you go along. You might think, well, it's boring making notes. I really want to read the next paper that the Google search found. Well, yes, but if you make notes as you go, it means that you organize your thoughts as you read the paper. So I encourage you to make notes on what it is you've read, why you think it's important, and then you can start to organize your material. And then finally, you can use this material either on your poster. That will be the first place where you use this material, on your poster, maybe in your movie, and certainly in your project proposal. Okay, so ultimately this is what you want to do with this material, is you want to use it. You need to follow this path. First of all, finding it, deciding that whether it's valuable to you or not, being organized, because you can't keep everything in your head, and I guarantee if you trust your computer will try to lose things for you, and then you need to use it effectively. So let's have a think about how we go about this. On this slide, and all these slides become available on Moodle for you, I'm listing a few of the search sites that I would recommend you have a look at. And we're going to look at one or two of them right now. But, you can type stuff into any of these. We're going to have a look at them in a minute. And they will produce lots of results. So it's a good idea to have a strategy. Okay, so first of all, let's have a think. What is it we're interested in? Maybe we're interested in transport. Okay, maybe our group has just decided this is the topic we're interested in, and now we're going to do a bit of a literature review and find out what people have already published in this area. So this is a huge area. Traffic congestion in urban areas. Where to start? Well, you can start with any one of these search engines, and you're going to want to type in some, so you select your database. Now, We're interested in transport. Do you think it's a good idea to go to a biomedical database if we're interested in transport? No. No. If we were interested in biomedical things, this would be great. PubMed is one of the most powerful search engines for medical information that there is. But if we're interested in transport, well, we could try one of the general search engines. So Google does everything, as does Scopus, as does Web of Science, as does Microsoft Academic. IEEE Explore, well, what does IEEE mean? Institute of Electronic and Electrical Engineers. Does that have stuff on transport? It might not be our first choice, okay? So, we're going to select some databases and we might try Web of Science. We might give that a go in a minute. Then that's going to give us a whole load of references and citations, which we're going to have to review. We have to read some of them, and then we might realize, okay, the thing I'm interested in is actually called something else. So now I'm going to search for that, probably in the same database, but you could try other ones and see what it comes up with. And you're going to go around this circle a few times. Don't underestimate this, identifying key concepts and terms. So in my own research, this happened to me about 2 years ago. My research team thought we were very clever. We thought we'd invented something completely new. It was not in any textbooks. Nobody seemed to have published about it. To my knowledge, nobody had even thought about this idea before. So we thought, wow, this is a really amazing discovery. And so we started writing up our paper all about it. And then we discovered that we'd just been searching the wrong thing. It was actually a new topic, but it did have a name, and other people were publishing papers on it. It's just that we didn't know what it was called. And why would we? We'd come up with the idea. Other people had come up with the idea. We weren't aware at that moment in time that other people were working in this area. But because we went round and round this, looking for information, then suddenly one day we realized, okay, the thing we're interested in has a name. And then as soon as you put that name into the database, boom, up come all the papers that are relevant to that particular topic. So about 3 months ago, we finally published our paper on the topic. And yes, of course, we made sure it had the right keyword in it so that when people look for it, they can find it. It's just like hashtags in social media. If you understand hashtags in social media, then you understand what keywords are. Okay. I'm also going to show you, it might be easier if I show this to you live, but I'm going to show you one of the things that we can do with some, not all, but some of these search engines. So let's say I'm interested in this topic of transport again. And let's say that I do a search and I find this paper here. Well, one of the things, of course, I can do is I can download that paper. That paper might have some useful information in it, and at the end, it's going to have a whole load of references. So whenever somebody makes a claim in this paper, so if they say, again, let's think about transport. If you've got somebody who's saying, well, there's this study on congestion in Sydney that was conducted in 2005, well, they're going to reference that. If the paper's been well written, you provide the references to the supporting information you need for the statements that you make in that paper. Okay? So when you read this paper, it's a bit like looking back in time. You can see the information that the people who wrote this paper used to support their arguments. Now, we've always been able to do this, even back in the old days of using paper. You've always been able to go back in time. What we can now do is we can go forward in time too. So let me explain to you how this works. This paper was published. Let's say it was published in 2005. If this paper has been valuable to people, then people in the future, so in other words, after 2005, will have said, yes, this study on congestion in Sydney, made some useful points, it's these. And of course, people in the future will reference this paper. Now, of course, this paper is static. This paper can't change. But what the search can do is it can say, okay, this is this paper, these are its references, but these are now the papers that have referenced this paper. Yeah, so maybe last week somebody wrote a paper that references this one. The search engine will pick this up. And that means that your search can become very powerful. So you can look, once you find a good paper, you can see what are the references in the past. Well, that can be valuable, but what can be even more valuable is to see what work has been done since this paper that refers to it. Maybe it says this paper is completely wrong for the following reasons. Well, that's really valuable information for you, because then you know, okay, I don't need to bother with this. Useless. Or maybe it says this paper was really valuable and turned out to completely revolutionize transport in Sydney. Great. This was a really important paper. So let me show you how this works. And folks, you're being very quiet. Do post questions if you've got any. All right, so just to prove to you how old I actually am, I need a different set of glasses if I'm actually going to look at my computer. If I need to look at you, I've got my fancy glasses, but my green glasses are what I need if I'm going to look at this thing. All righty, so this is Web of Science. Okay, I would recommend it for sort of scientific things, for engineering. It's, as the name suggests, it's mainly to do with science. Other search engines work in much the same way. Now, let's say we're interested in a topic, maybe. Let's put in, I'm going to try an experiment here. Actually, no, I'm not going to try an experiment. I'm going to look up one of my own papers, okay, just to give you an idea. So, we're going to search for my name. I've got this slightly unusual name. But I also have a sister who has the same unusual name. So if you look up my unusual name, you won't just get me, you also get my sister. And she publishes in a completely different field. That's maybe not, that means the search results are going to be a bit annoying. So what we're going to do is we're going to type in my name, and notice I've changed the search here to author. Okay, so unlike in Google, where it just search everything, and Google works quite well, but here you can be much more specific. You say, I'm only interested in the author with this name, and I'm only interested in an author whose name begins with N. So, you know, maybe I've just used my initial, N. Maybe I've used my first name and my second name, okay? Or, you know, some strange combination. So N star just tells the Web of Science search, okay, I want somebody whose second name is this Eakins-Dorks, and I want, it doesn't matter, they have to begin with N, otherwise we're going to get his sister, but it doesn't matter what comes after N. So the star's like the wild card. Okay? So you can say, right, let's do that. And so we press enter, and things happen. So now it's found some papers. And we can see, it's a tiresome thing with getting old. If I'm going to read this screen, I need different glasses. All right, so we can see some papers. And it looks like it's doing it by some sort of sorting it in terms of date. I can change how it gets sorted at the top of the screen. I mean, I'm sure you can figure all this out. You know, it's sorting by date. So here's my most recent paper. Here's the next most recent paper, and so on. Now, let's scroll down a little bit. Oh, let's notice on the side here. Here it says time cited. Now, that's quite useful. That's the number of times this paper has been cited. Now, that paper was only published not last month, in December. So not many people have had a chance to, let alone read it, notice it's there, but also then think, oh, yes, that's an amazing piece of work. I'm going to cite that piece of paper. Yeah? So that's why it's got 0 citations. Let's say, okay, well, let's say we're interested in what this amazing author is doing, but let's do it now by time cited. Yeah? So this is now going to show you some of the more highly cited papers I've published. So, you know, you can see there's one there that's got 233 citations. So let's say you happen to be interested in that field, and you realize, this actually was kind of a breakthrough paper, this one. It's been cited since whenever it was published, 2012, so in the last 8 years, 233 times. That's not bad. And Web of Science is very kind to you if you get lots of citations. It sort of gives you this sort of prize, highly cited paper. It's not really supposed to make me feel proud. What it's supposed to tell you is, in this field, this paper seems to have attracted quite a lot of attention. So it's just a computer algorithm that's saying, okay, this paper seems to be one that people quite like. And so you can say, okay, I mean, I wouldn't use this. This is just a machine that's making this judgment. It's not a human. So, you need to make the judgment. But you can already see the Web of Science is trying to help you identify which of my papers happen to be, influential. Okay, so now I want to show you how this lookup works, this sort of forward lookup. This was published in 2012, 8 years ago. Now we're going to look at all the papers that have cited it since it was published. So what we do is you just click on that, and the thing does some thinking, and now you see a great long list of those papers. And of course, it's starting with the most recent ones, so you can see various results that seem to be building on that result we published 8 years ago. So if you happen to be really interested in that result 8 years ago, you might want to go through and review the various papers here. But you've got a lot of papers to review. 200 and something, 33 of them. How on earth do you decide quickly which ones to read? Well, the first thing you can do is you can look at the title. And you can say, right, well, I'm not particularly interested in the first one because that's not, maybe I'm not interested in this chemical, and maybe, but I am particularly interested in this one. Let's say I was interested specifically in eczema formation for whatever reason. That was what your thing is. Yeah? Then you say, great, I found a useful paper. But before you download it, you're going to want to find out a little bit more. So if you click on it, what it will do is it will take you to the abstract. Now, I'm going to ask for a show of hands. Who knows what an abstract is? Yes? A summary. Very good. Exactly. So it's a strange word. For those of you who, thinking, well, hang on, what is an abstract? Gentleman's absolutely right. It's a summary of the paper. And the reason we have this summary is precisely for this purpose. We've got 233 papers that we're wanting to review. Let's say from the title you identify 100 of those papers to be interesting to you. Are you really going to go away and read a paper really, really carefully? And in the old days, I actually had to go get the volume off the shelf, find the right page, open it, and then you have the full, The abstract is a really useful summary. It should contain 1 or 2 sentences that describe what this is about. Okay, so, the very first sentence here is just explaining what this topic is. Then the next couple of sentences will be the key results of the paper, and then, some kind of conclusion. But it's extremely condensed. You can't prove anything in an abstract. It's just a summary of the key results. So you've read the title, and you think, yes, this looks like the right sort of thing. Then you'll read the abstract, and you say, great, this is exactly what I'm looking for. How do I download the paper? Well, there's a couple of different routes. At the top here, you can look up full text. You could find it on Google. There's a number of different links. And if you choose to use the Web of Science, you'll find that one of these will work. I wish Web of Science was more reliable. I personally like it because it does this reverse lookup and it's quite well organized. But to actually get the full paper, you can try clicking full text. Maybe 80% of the time that works. When it doesn't, try one of these other things at the top. And if you're very unlucky, it might be in an obscure journal that UNSW doesn't subscribe to. But that's a relatively unusual situation. Okay. Yes, very good question. If abstract equals summary, why don't they say summary? All right, so What we've done, so this is kind of like an English language thing. Obviously, summary is a common word that you all understand. Why do we say abstract? Well, what we're doing is sort of abstracting the key information from the paper. So, you know, the history of using this word, abstract, is, you know, it's quite old. It's been used for decades. I mean, 100 years ago, a lot of scientific publishing took place in German, for example. Yeah? And so, and we still, in science, sometimes use German words simply because we, not me personally, but our ancestors were used to reading science in German. So, you know, abstract is one of these sort of slightly dated words. These days, yes, summary is exactly what it is, but we continue using this older word abstract. And in some ways, you know, English language is full of words. But for most of you, the English language will be your second or third language, and you've struggled like hell to learn it. And one thing you will know is that it's got a lot of words in it. So yes, we could use summary. We choose to use abstract, because in this case, it's just a little bit more precise as to exactly what we mean. It's a very short, you know, an abstract. It should be a single paragraph of text, just like this. No figures, just some couple of sentences that describe the content of the paper. Okay, another question. Are there any important points to remember whilst writing an abstract? Well, yes. So you need to think very clearly about what it is you're wanting to report. Okay, so, you know, the first sentence here, I'm going to need to take off all my glasses to read this. Perylene is a promising annihilator candidate for triplet annihilation photon up conversion. Who actually understood that? Probably not many of you. The point is that if you were really into this topic, that would make some sense. Let's go and find a slightly friendlier paper. Let's look at, for example, this one, which has, yes, some very accomplished authors. Right, so fundamental losses in solar cells. At least the title might make sense to you. Yeah? It means something to do with solar cells and some way in which we might lose energy in solar cells. And so, what does the abstract say? The first sentence, this paper considers intrinsic loss processes that lead to fundamental limits in solar cell efficiency. Okay, one sentence that just describes, without too much jargon, what's going on. So if you're not interested in solar cells, if you're interested in wind farms, you say, okay, bin, not interested in this paper. Actually, you would have figured that out just by reading the title. And then the abstract will carry on. It will talk about, you know, what some of those processes are and how we, in this particular paper, have dealt with them. And then towards the end, we've got some concluding remarks about what it is we're reporting. Okay? I think one of the best ways of sort of figuring out how to write an abstract is to read them. And sometimes you'll find abstracts are quite confusing, a bit like the first one I started reading, which sort of goes gobbledygook, 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 gobbledygook. And when you read an abstract like that, it doesn't mean that the paper's bad. Perhaps it doesn't even mean the abstract's bad. It just means it's about a topic which right now isn't going to be useful to you. Because if you don't understand the abstract, you're not going to understand the paper. But if, for example, you happen to be interested in solar cell efficiency and you understand the first couple of sentences in the abstract, you think, yeah, okay, maybe I can read this paper. Okay, and then look at the structure of the abstract, and you'll see that if it's been well written, every sentence counts. There's no sort of weak sentence that says, yes, we investigated various things and we report our results in the paper. Yeah? That's a useless statement in an abstract because it tells you precisely nothing. You know, we reported various things and they are in the paper. No, you might as well just say a paper exists. I mean, just don't even bother saying it. Okay? What you do want to say is we conducted this experiment testing concrete using hammers. Yeah? If that happened to be what you're reporting on, great. You tested concrete using hammers. And we found whatever. One top tip. I see I have more questions. That's good. One top tip. In science and engineering, we tend to write in a particular style. And you'll notice this is particularly prevalent in abstracts. People tend never to use, in fact, they never use the word I. We never use the first person when writing an abstract. And it's extremely unusual to use the first person even when you're writing a document. And you might ask me, why is that? The reason is because you don't matter. Whether we were testing concrete with hammers, let's say. It doesn't actually matter whether it was me or the folks in the front row here or whoever tested concrete with hammers. The person doesn't matter. So what you say is concrete was tested using hammers. Yeah? You keep the people out of it. Sometimes people use, we tested concrete using hammers. That's just about acceptable in an abstract. But what you never say in abstract is, I tested concrete using hammers. Nobody cares whether it was you or somebody else. The point was, concrete was tested using hammers, and you discovered some interesting results. All right, how long can an abstract be? Good question. So you can see the utility of an abstract on the screen here. If you're going to read an abstract quickly, you don't want it much longer than this. So the abstracts that we write for scientific papers are usually very short. Single paragraphs, couple of sentences. Few hundred words at most. Okay, if we can understand the complete content for an abstract, do we need to read the complete paper? That depends. It depends. The whole point of the abstract is for you to be able to judge, is this paper worthy of my greater attention? Does it help? Remember that circuit? Maybe we should quickly just go back to that circuit. In this circuit of finding information and then evaluating information, you're going to do this review and refine search results. As part of this, you need to decide, is this paper actually worth reading? Because if you're going to read it properly, that's going to take you at least 20 minutes. So the question you're really asking yourself is it worth me spending another 20 minutes reading this paper? And if the answer is, well, no, the abstract, it kind of looks like it's not really addressing what I'm interested in, or maybe, yes, this paper might be interesting, but right now it doesn't seem to have the information I'm looking for, you might keep it, but you might decide to read it later. That's the purpose of the abstract, it's to help you make that decision. Does this paper have information in it that is useful to me at this moment in time? Do abstracts include end results? Yes, is the short answer. If I've done an experiment and, I've got a result at the end of it, so, for example, I was talking about testing concrete using hammers. Why might I want to do that? Well, let's say there's been some problems with high-rise towers in Sydney. Anyone read the newspapers? Opal Tower, cracking of concrete. Yeah? Maybe I've gone away and done some tests. And in my abstract, I'd say, yes, we conducted tests. We hit concrete with hammers, as people might do on a construction site. And it would be a real shame if your abstract stopped there. Leave your audience in suspense. Well, all right, what happened? Did the concrete break? Have you solved the problem of the Opal Tower cracking? And then, yes, so of course you should put a sentence or two saying, yes, and we found that if you hit concrete 100 times with a large hammer, it cracks, or not. Yeah? So definitely, abstracts should include the end result, towards the end. So the first sentence or two introduces it, next couple of sentences might describe what was done, and then the key findings, you can never squeeze in all your findings, are at the end. The full paper, of course, contains the fully justified and professional document that describes how you got to those conclusions. Yeah? Precisely how did you conduct those experiments? And the point is when you write a paper, it should be such that anybody could come and repeat that work. If people can't repeat your work, then that's not a rigorous piece of science or engineering. So in the paper, there'll be a lot of detail. We cast concrete in the following way, following pressure, following temperature, in the following form. We let it dry for however many hours, okay? All those details you're never going to be able to put in the abstract. But they're, of course, really important if you're interested in the details of this work and if you want to repeat the result. Okay, so yes, at times you're going to want to read the full paper. The whole point of the abstract is to help you locate it. All right, so we've had a look at a few of the things that Web of Science will do for you. What you can also do is you can have a quick look at, particularly if you've searched a particular person, and this case we haven't have searched myself, you can click on this one, Great Citation Report. Now, what does that do? That shows you how busy this particular person has been. So it shows you, how many papers I publish a year and all these things. It also has this thing called an H-index. If you look up me, well, I've got this H-index of 36. What we're going to do is we're going to flip to one of my esteemed colleagues. And just for fun, let's use a different search. Let's use Google Scholar. Okay, so Google Scholar, you can type in someone's name. And here we are. Here is one of the professors who's in our school. Now, Martin is pretty much established photovoltaics. He's written more books than I can remember on the topic. And so, yeah, you can look at his output. It's extremely high for a researcher. He's at the end of his career now. But my H-index was 36. Martin's is 128. What does that mean? Okay, I'm a sort of relative, despite the fact I need 2 sets of glasses, I'm still young, yeah? But, yeah, what's this H-index thing all about? So let me explain it to you. When we publish papers, you've seen that we can publish lots of papers, and then other people, if they find your work useful, will cite them. So the H-index is actually a relatively simple thing. If I publish hundreds of papers, let's say I was really busy, every week I publish a new paper, but if nobody ever cited my papers, my H-index would be 0. Okay? Because what the H-index is, so there's a little definition of it, it's the number of citations in some period divided by the number of publications. Probably easier to see this in a graphical format. Here, if we stack up the papers that I've published, so this is number of papers, and we order them by the number of citations. So let's say I'm a somewhat famous researcher. I've produced a few papers that people really liked and got a couple of citations, but most of them are not so high. The H-index is the point where the number of citations equals the number of papers. So when I say I have an H-index of 36, it means I have 36 papers that have been cited more than 36 times. That sounds all right. It sounds like people kind of quite like what I publish. In the case of Martin Green, on the other hand, he's published 128 papers that are cited more than 128 times. Wow. I've probably only got about 5 papers that are cited 128 times. Okay, so as you progress in your career, your H-index can only go up. because you publish more papers and you get more citations. But the reason I'm showing you this is because, let's say you find an author, some professor who seems to be publishing work that you think, okay, this seems interesting, but I want to know, is this person, considered to be prestigious in the field? One of the things you can do, and I just showed you how you can do it in Google Scholar and Web of Science, is you can look at the H-index. If the H-index is like 10, it means they're probably quite a junior person. They haven't published either very many papers or haven't got very many citations. That doesn't mean their work's bad, okay? We all had to start somewhere. We all had an H-index of 10 once. But if you find somebody like Martin Green who's got an H-index, of 128, wow, that means you found one of the key people in this field. And yeah, if they're publishing in stuff that's useful for your research project, great. You probably want to read quite a lot of their papers, okay? Doesn't mean that other people's papers aren't valuable. It just means that within the community, that's a researcher who's getting a lot of attention. Okay. So, on this topic of reliability, what would be the most reliable? Oh, well, I've gone and given the game away now. What would be the most reliable source of information? Yeah? You saw it. Books. So if, before you even go looking for journals, if you find a book in the library called, Problems or Dealing with Congestion in Sydney's Motor Transport, okay? Great. The book is likely to be a really useful, comprehensive, reliable source. And definitely, you should look at some books when you're doing your literature survey. But, of course, books might have been published 20 or 30 years ago, and maybe they're not up to date. So what do you do? Books will have accepted information, extensive background and context. But if you want to update yourself, what's happened more recently? Well, then you look at the journal papers. And I've shown you how you do that now. So maybe even in the book, there's a reference. It says, oh yes, the precise topic you're interested in, here's a paper. Well, what you can do is you could search that paper using Web of Science, and then say, okay, that paper, of course, hasn't changed since the book's been written, but other people will have cited it. So I can use that paper as a kind of clue that will lead me to other papers that have been published much more recently. So, the journal papers, of course, are much more up to date. So you get the latest findings. Importantly, journal papers are peer-reviewed. What do we mean by peer-reviewed? What that means is when I write a paper, I write it, I send it to a journal. The journal then sends it to 3 or 4 other researchers that it thinks are competent. I might disagree with that, but, the journal will do that. And then those reviewers will then write back and say, yes, this is an amazing piece of work, it should be published, or no, this guy is completely mad, it shouldn't be published at all. Or what usually happens is somewhere in between, yes, this is an interesting piece of work, but would be better if you did the following things. So the point of peer review is it means what goes into a journal has been checked by a couple of experts. Those experts, of course, can make mistakes. They can also be lazy and not do their job properly. So there are mistakes in journal papers, but journals are usually pretty reliable. Similar to H-index is something called journal impact factor. What that means, if you have an impact factor of 10, it means many, many, many people reference what's in the journal. So for example, impact factor 10 means, on average, this journal gets 10 citations for every paper it publishes. If it has an impact factor of 0.5, it means that some of the papers never get referenced. So, journals also have a sort of prestige attached to them. And if you're interested, you can look up the journal impact factor and see, okay, am I reading a really prestigious journal here? Or am I reading, some kind of web article that maybe hasn't been reviewed very rigorously? Then there's conference proceedings. So I'm going to show you a little bit how conferences work in another presentation, but a conference, of course, is when many scientists and engineers come together, they talk about a particular topic. So we could have the International Conference for Motor Transport, for example, yeah? And then they might have a volume that records papers that people presented at that conference. Okay, so it's a record of the material that people presented at that conference. Now, I put that under journal papers in terms of reliability. Well, because these conference papers are probably not peer-reviewed. You know, I can put up my hand and say, oh, I want to go to this conference, and this is my submission. You know, flying cars solve Sydney's transport problem. Well, maybe they let me into the conference. Maybe they think, oh, yes, this humorous Englishman, yeah, we'll let him come in and talk about his flying cars. But, you know, whether you've been accepted in a conference or not really is nowhere near the same level of scrutiny that you get with a journal paper. Okay, so you sometimes find some slightly odd things going into conferences because people are sometimes full of enthusiasm but perhaps haven't thought as clearly as they should have done about what they're presenting. The value of a conference paper, though, is often you'll find people publishing useful details in conference papers, but the major findings will be in journal papers. So if I make a discovery that's going to win me a Nobel Prize, I probably will publish it in a journal paper first, and then I'll go to lots of conferences and be very famous explaining to people this wonderful discovery I've made. Okay, so in the conference paper I might put details, but the real paper that it really matters is the one in the journal paper. Now, grey literature. What do we mean by grey literature? This is where there's quite a lot of useful stuff that's just on the web. Yeah? So, you know, you'll find lots of things like Wikipedia, for example. I put as grey literature. Hugely useful is Wikipedia. The thing is you can't really tell, is this right or not? Okay? But it's there. And maybe, for example, we were talking about how it can be difficult to find the keywords to do a journal paper search. Maybe the first article you read is a Wikipedia article. And maybe that tells you, yes, this is the key word, or here's a